been doing a little bit of measuring of these two castings. Now clearly identified as number 1 and number 2. They're both slightly different thicknesses, but the depths of the recesses are very similar, within something like 10,000ths of an inch. So they're good accurate castings again. These outside rims are uniform thickness all around, so that's great. So and these bosses are centered pretty nicely in the part, so it should be straightforward to make these look, well balanced. They are sort of wedge shaped where the gate is, the casting gate, which I've cleaned off a bit by hand. They are thicker in this area than other areas, but there is sufficient stock on both to clean up properly. So my sketch here is just taking measurements of the thinnest and thickest area on each part, and trying to figure out how much to take off. So what I've established is that I want to take off 55 thou roughly off of the face of each part here, so that on this surface they look the same, and that means on this one I have to remove about 55 thou from the thinnest point, so from uniform cleanup, and this one I have to take off about 90 on the back from uniform cleanup, and then that gives me just enough to completely clean up the faces, and that gives me 30 to take off the front of that one, 45 to take off the front of that one. So that's going to be the plan. I'm going to basically take these down to final thickness on the back side on the milling machine, turn them over, and then I'll probably do a minimum skim on the front so that I can drill and ream holes, and the same here, and these holes will be undersized initially, and then I'll transfer them to the lathe. And I'm still toying with how I'm going to hold them on the lathe, but I think I might make an expanding arbor, a very close fitting arbor for the center hole. So it's either that or pressure turning them, but if I pressure turn them, then getting to this front face will be difficult, so hence the expanding arbor idea. But I think I'll face the back and put the holes in first, so that's next. For setup, I think what I'm going to do is clamp the part in my milling vise, and I'm using these two V blocks, and the reason I'm using these is this allows me to rest the part on the outer perimeter here on top of the block, so that these are small enough that these radii, sorry, let's get this back in front of the camera. Where's my pointed stick? The boss has a radius here and another one here, so I don't want any V block to touch on that, because that will stop this seating against this. But these two V blocks are small enough that they can sit like this, and now this radius feature won't interfere. I tried this same arrangement with larger V blocks where the V would come across here, and now this wouldn't sit flat. And you have to trust something on a casting. There is no machined surface at this point, so you have to do something. You either have to put it on I guess you could put it on a sanding machine or take files to you, but you have to trust something. And what I've established in measuring it is that this surface is as good as any to at least get started. So I'm basically going to skim this face flat relative to that, and once that's done, then this will be my reference surface. So I'll get that set up and we'll make a start. A lot of waffle in it still. Thickest part of the casting is here, so this should be my highest point on this plane. This plane should be kind of sloping this way. We will now find out if that's true. That's all I'm going to take off of the back for now. I'm going to leave some on it to face off on the lathe. I was originally going to take this all the way down, but I've changed my mind. Just because. Hedging my bets, I suppose. That is sitting down nice and flat, so I'm happy with that. That gives me a good registration surface. So now I'm going to set up and, well, I suppose I should skim the other one first. Let's do that. I'm not going to make you watch both of them. The operations are going to be the same for each, but I'm going to now clean up the rear side on the other casting as well. I've now got this crank web set up on the mill, as you can see, and the next stage is to get a 1/2 inch hole drilled and reamed through the middle of this boss. That's going to be used to fixture the part on the lathe to finish turning the front of this face and the front of this boss, and also the back side. Now, my original plan was to put a 1/2 inch hole through here and another hole, a smaller one, through there. I'm not actually going to do that at this stage. I'm only going to do this one. And then my plan is, once both crank webs are machined on the lathe, I will clamp them together using a gauge pin to align the bores, and then I will clamp them and I will get these two features aligned on either crank disc, and that way I can finish boring this hole to size, which has to be 5/8, and then add this hole, which is has to be 3/8, and I will put those two holes in together with the crank webs clamped together, so that I have this distance between these two bores identical on both. I think this machine is accurate enough with the digital readouts that are on it that I could just do them separately, but for the sake of safety, and since these parts have to work together, I'm going to machine them together. So, okay, so how to center the hole in this boss? Well, I've measured this boss and it's actually round within 20 thou, which is actually pretty reasonable for a casting. So I'm going to just use an edge finder, and I'm just going to touch off on either side here to get a center position in the X direction, and then the same in the back and front to get the center in the Y direction, and that should position the hole centrally. Once I've center drilled it, I will take some additional measurements and just verify that it's quite close to center. This technique only works because this is sort of round. If this feature was not at all round, then you'd have to use a different technique, line it visually or whatever. And I could do a visual alignment using a gauge pin, but I don't have one this big. Got on pretty close. But I think, given that this is a decent geometry, I think this is as good a technique as any. So that's what I am going to do. As you can see, I've got it sort of centered, but that's actually not critical. You can actually find center off of a circular boss by touching off anywhere on it, as long as you touch off on equivalent places in the X and the Y. Anyway, here we go. 'Alright, now that should be pretty well centered. So what I'll do is I'll put a center drill in there, put a mark in there, and then take a couple of very crude measurements, but I think this will work out quite well. Five, 8, 7, 5, 8, 7, 5, 8, 9. So, you know, admittedly, that's a very rough measurement because we've got this radius around the top, and we're sort of measuring from this point and kind of tipping the calipers down, but we're doing it in a similar way around, and I think it just demonstrates that that is centered as visually as well as it can be, I think. So at this point I'm going to go ahead, I'm going to drill a pilot hole, and I'll measure it again because I still have the opportunity to correct things at this point. If I go a little bit at a time, I can measure, and if I do think it's way off, I can always go off center, reposition. I can always get the boring head out and rectify it that way, but I don't think I'm going to have to do that. So that's next. Okay, so that's reamed slightly undersize. That's a 499 gauge pin that I'm putting in there, and that's fine because this is a fixturing hole at this point. This is not the finished hole. All that matters to me is that this hole is consistently the same as the other crank web, which it is because I already made that. And the same gauge pin fits in both, and the 1/2 inch gauge pin will not fit in either one. So that's great. So now what I can do is turn the OD, turn this face, turn the back face to final thickness, and finish these up, and then we'll come back to the mill, get this hole on final size and add this one. So stick around. Here's my little expanding arbor, expanding collet, whatever you want to call it, installed in my ER40 chuck, and I just got a DTI here, a dial test indicator. I just indicated the face of this as well as this diameter. These were both turned in the same chucking operation, and I've got both the face and the diameter less than 5/10 of a thou, so I'm very happy with that. And what I'll now do is mount up one of the crank discs, and I'll perform the same check on that. That's a nice tight fit on there, so that when I tighten the screw, it feels good and secure. I'm going to give it another torque. I've put it into back gear so that I can put a little more torque on the screw. Yeah, that should do the job very nicely. Now, the idea here is that I can assume that the bore is true, but I'm going to clock the back face for sure, and since I've got room in there, I think I will attempt to clock the bore as well, just see what we've got. I went off camera there to get this trued up a bit. It took me a bit of finagling. The run out of the back face, which was machined, is a couple of thou, so a bit disappointed in that, and I wonder honestly if my tooling plate is as flat as I thought it was, or as parallel between its two surfaces. I suspect not. Might have to take that into work and find out. We got the equipment there to measure that properly. However, I deliberately left machining stock on the back side to deal with that should it come up. So my plan is to again turn the OD to size now, clean up this face and the front face here, and machine part of the back side in the same operation. That way when I turn this around to finish the back side, I can clock the back on that outer track and make sure that I have it running true. That's going to be critical from this point on, so that's what we're going to try and do next. First off, clean up passes on the OD and on these faces, and then I'll take some measurements and see where I'm at. It's a bit of a balancing act because I have to maintain front to back dimension on the boss and front to back dimension on this. The OD is not difficult, that's just the diameter. In terms of speed, I've got it set up to run 300 RPM. Doing surface footage calculations for cast iron with a carbide tip has this coming out about 500 RPM, but I feel more comfortable running it a bit more slowly. I think that's okay. So 300 is kind of where it would come out running a high-speed steel bit, but since this is cast iron, just in case there is some tough spots, I'm going to use this carbide bit anyway. So, alright. Wish me luck. Now, starting to clean up. Let's well, set up the automatic feed. Well, according to this micrometer, I'm dead on. 3.31. Guess we'll take that.